Morning, everyone. I hope everyone is doing well. Welcome again to our webinar series for today. We'll be going through troubleshooting a guide for failed external quality assessment. So for this particular guide, we'll be able to go through what are the expected results that you need to get, what are the indicators that show the EQA has failed, and now we'll be asking the questions on what happens if these results are in this particular way, and how we'll be able to troubleshoot. So as always, we'll be able to start at the hour mark, and then we'll be able to finish by 8 a.m. and then we'll go through a series of Q&A. So feel free to put your questions on the chat box or on the Q&A section, and then we'll be able to handle it promptly. For this webinar, I will be taking you through. Mr. Antony will be able to join in maybe later on, but we'll be able to start off today's webinar. All right. So feel welcome. And then in case of anything, just put it on the chat box. And then at the end of the session, we'll be able to open up the mics. And then you'll be able to ask the queries that you might have. So welcome to our webinar series number 6. So our objectives for this particular webinar is we need to understand the EQA performance report. So the reports that you get, what are the expected results, and what do we call when we say that we are troubleshooting a failed EQA. We'll be able to identify the sources of the unacceptable results and how to handle them. We'll be able to apply systematic troubleshooting steps, and then we'll be able to implement the corrective and preventive actions. So we'll be able to start with a brief on what we are targeting and what we aim at getting. This particular guide will focus on, once you get your external quality assurance performance report, we'll be able to help you understand the quality of the lab test results. So once you do an EQA, usually the EQA provider that you are using to give you the reports should be able to give you a training on how to interpret those particular reports. Case in point, there are statistics reports that are included in that particular EQA, and you need to understand what they mean and how they are calculated. Once you have that particular feedback, the EQA provider should also be able to give you notifications that shows that this particular EQA has failed or this EQA has passed. In some cases, you will get different kinds of reporting techniques depending on which region the EQA provider is coming from. So for the Europe, USA, you'll be able to get indicators like either the red, green, and yellow kinds of traffic lights report, where you'll be able to be indicated as green, you are within a certain range that is acceptable, yellow, you are at a warning signal, and red when you have failed that particular EQA based on the acceptable limits. The acceptable limits we'll discuss are the Z-scores or something we call the standard deviation index. Both are used in the same way, the Z-score or the SDI. Other reports like the one we do, ESF EQA, you'll be able to get signs at the end or at the left of your report. So no sign will indicate that you're within the acceptable Z-score. A small bomb sign will be indicative of a warning signal. Remember, a warning signal is not a failure unless your EQA or quality manager or your organization accepts 2 to 3 as a fail. So depending on your guidelines for your organization, some organizations might be too strict and they will say we only accept a Z-score between 0 to 1.9999. So a 2 to 3 is not a failure, but a warning signal. So warning signals usually just indicates for you, check on this particular EQA before the next survey. Now for our EQA also, the Z-score above 3 will be indicative of an action signal. Remember, an action signal, you need to work on it. So yes, you are doing your root cause analysis, you need to identify the fault and then do a corrective action so that the next particular EQA that you'll run, you have already solved that particular issue. So that's just a brief of that. Other organizations will be able to give you percentages. They will be able to say, out of 100%, you got a 70%. So the 30% that you failed, you'll be able to check on it and see why the failure was there. So simply, that's how you'll be able to see failure mode or the interpretation side. So EQA should be done in combination with the IQCs. So as we discussed on the importance of third-party controls or the importance of QCs, remember EQA also should be done as well. So the EQA will allow you to see how your lab is performing compared to a group of your peers. This is another important thing that you need to note. There is a report that you will get. There is a general report for all participants. And then there will be a peer report for your particular instrument, particular method, or particular reagents. So remember, a good EQA provider should be able to give you a general report and a comparative report against your peers. We will see why peers is important in the next slides. So all your results in your EQA performance report should be examined for unacceptable results, unusual trends, sudden shifts, or other problems. Unacceptable EQA results can arise from systematic or random sources of errors. The systematic errors are shown for all your EQA results on one side of the target, and a bias is seen, whether positive or negative. So these are known as the systematic errors. In an example, all your EQA results are below or above the peer group mean. So you've done your EQA, and all your results for sample A and sample B, both are on one side of the mean. We'll be able to identify those sources of errors as a systematic error. While a random error will be shown by results that are on an average close to the target value, but there are a few exceptions that show large deviations from the target value. These are known as the random error. You have some results that are very close to the target value. It means that they have performed well. So an example, you have sample A and you have a very good Z-score over 0. And then you have sample B that has deviated, either the plus side or the negative side. We'll call them the random errors. So systematic errors will point to some issues in the system, while random errors will also point to other issues in the system. So we'll be able to differentiate those two. And once you identify the source of the error, it will be easy for you to be able to troubleshoot. Because there are several guidelines that we'll follow when you have systematic errors, and there are other guidelines we'll follow when we are having random errors. So for us to understand this particular topic, it's very important that we know what we are targeting and how we'll be able to address them. All right. So this is a very important question that you need to ask. Were my EQA results within the acceptable range? And we have already discussed, if you are using the EQA provider from ESF EQA, there will be no sign on the left side of your table of results. You'll have a small sign if the results are within the 2 to 3 SDs. Not a failure, but a warning signal. Remember, don't say you have failed if that particular Z-score is between 2 and 3. And also, anything above 3 SD will be considered a failure. We'll also focus on do you have any peer grouping in that particular report? And we'll be able to see which peer group is best characterized to view your report, so that if you have several results under the same peer, let's say HB results, you get general, you get instrument, you get method, you get reagent groupings. So if general has a z-score of 3, instrument has a z-score of 0.5, method has a z-score of 0.1, reagent has a z-score of 1.5, will you consider your results as a fail or a pass? So you'll be able to see which peer grouping or hierarchy is best characterized for your grouping, and you will be able to see significantly also on the left side of your AQA, no alert signal if other grouping are okay. So the instrument is the best characterized group for you. You will also truncate it to method, reagent, if these particular groupings are there, and then general if nothing in the peer groups exist. And we'll see why it's important to have those peer groupings, and we'll go back to something called configuration when you are setting up your EQA. So participant data and comparative group data would list the information that will indicate the EQA result is satisfactory or not, and also how it compares to other labs. So how you compare with other labs will also be indicative of your peer grouping. That's it. It's very important when you get those particular results and you failed HB. Go to the other pages of the EQA report. Don't just end up at page 1 to 5 and you're satisfied with that. Go to further down the report and you'll be able to look at HBD in depth, where we'll focus on, we'll see the comparative between other instruments or other labs and your results. So for an example, if you get a HB of 20 in that particular EQA, go to the instrument grouping section. Look, is there any other laboratory or any other instruments that were getting a higher result as mine, or it was an anomaly on my side only? This will also help you know what you are targeting. So any results that are marked outside the acceptable range are signified by a mark. The z-score or the standard deviation index is a measure of the distance or bias of one result compared to the mean results of its peer. The greater the z-score or the SDI, the further it is one result from the mean of its peer group, which indicates deviations from normal performance. So remember, you have a result of 20 and you have a mean of 25. So for us to calculate how far you are deviating from this mean that we got, we don't subtract 20 minus 25 and we say we have a deviation of 5. No, we'll have to calculate the standard deviation. Standard deviation is already discussed in another webinar. So once you calculate your standard deviation, will be dependent on, are you having a relative deviation kind of impact? And these are usually incorporated from the performance of that particular analyte or the allowable limits. So we'll be able to calculate your standard deviation. Now, the standard deviation index, which we also call z-score in our reports, is now that deviation from the mean. The acceptable range is determined by the evaluation criteria for that particular analyte, remember. So each particular analyte have their own acceptable range. And once this acceptable range is obtained, it will determine how we are calculating that standard deviation. If an evaluation criteria for a peer group of plus or minus 2SD, then the target value is determined from the results submitted in that peer group. After outliers have been removed, we will then add and subtract 2 standard deviations from the mean to get the upper and the lower limits. So sometimes you might ask, for QCs, it's very direct how you usually calculate your standard deviations. So the standard deviations will be, you have an IQC, you have a mean, and then you are given the upper range and the lower range. So how do you calculate the standard deviation? So if you are using the 3 SDs, you'll take upper limit minus lower limit divided by 6. So when you divide by 6, it means 1 SD will be the difference between the mean of 0 to plus 1 or minus 1. That's 1 SD. When you go to plus 2, that's a 2 Z-score. When you go to plus 3, that's a 3 Z-score. So remember, in our grouping, we have the upper limit and the lower limit. So difference between up and low will be a difference of 6 standard deviations. So that's how you calculate in your IQCs. Now for EQA, you have been given something like general mean, and then you are given an SD, and then you are given your target value. So it's very easy for you to calculate what was the upper limit and the lower limit. So if your mean was 20 and your SD is 5, you can just simply calculate the upper limit and lower limit. So the upper limit for plus 3 will be 20 plus 15, that is 555, and then 20 minus 15, that is 555 on the lower side. So it means my lower limit will be 20 minus 15, which is 5, or 20 plus 15, which is 35. So easily you can calculate what was the upper limit and the lower limit, because in the EQA scheme, you are not given the upper and lower. You're just given the mean, the standard deviation, and where you are on the mean. That's simply how you calculate that. What is a peer group? So a peer group is ideally a group of labs that are using the same instrument or reagent for that particular analyte. We can go further and add a method and an instrument method group, the general group, and the reagent group. So similar instruments using the same kind of method or same kind of reagent will be grouped together. So if you're having Sysmex XN550, they can be grouped as the Sysmex XN550. We also have maybe XN600, so they can be grouped together. So different peer groups will determine how you are grouped. And when we say you are grouped under Sysmex XN series, will be all the XN that are there. Either it's 350, 500, 1000, they can be grouped together. When we say the Sysmex series, will include Sysmex XN, Sysmex XE, Sysmex XS, and so on. So there are several groups that you can be grouped under, and they will be determined by a minimum number of 5. So if we are having a Sysmex XN grouping, but there are 3 participants only. So this is Sysmex XN 350, 3 participants. Sysmex XN 500, 4 participants. So we are not able to give this particular labs grouping for their individual account. We'll pull them to the next grouping, which is now the Sysmex XN series. So anybody who has an XN, they can be grouped in that. And that's where we'll pull so many numbers and be able to get an above 5 peer grouping limit. So instead of us giving you general, we now call you a grouping Sysmex XN series. And these are determined by the EQ provider once they do the analysis. Then we can also say that this Sysmex XN series now, there are only 3 participants. And then we have the Sysmex XE, Sysmex XS, but these particular groupings are from the Sysmex group. So we can also pull those groupings together and put them in a Sysmex group so that they are able to get the peer grouping. So if you have understood what the peer groupings is, then that's what it means. So what happens when you get a reagent grouping? So you find these particular instruments that are open systems. So you have a biobase that is using Mindry reagent. You have a Mindry using Mindry reagent. You have a biosystems using a Mindry reagent. So we can be able to group these particular labs despite their different laboratories, but they are using similar reagent. And then we have a very important group that is usually called method. Now, method is dependent on so many factors or so many machines. So we'll have ALT using IFCC method. So you find these manufacturers are using this particular method for analysis. So out of 40 different machines, but they are using the same kind of method. So we can be able to group them. And this usually points out a very clear distinction when we are analyzing. So you find that instruments that you are using dry chemistry method will have very varied results compared to wet chemistry method using maybe IFCC. We'll have other analytes that use DGKC method or IFCC. There are 2 different methods, but they will get very different results. So they are very important that we also grouping you according to the method you are using. So these peer groups you are evaluated in is shown by a small print under the comparative group data heading. So you'll be able to see that I, G, R, M, etc. So if a peer group consists of labs that use the same let's say that bearing dimension is series instrument, note that depending on the number of the peers, your peer group might change from one test to another and might be graded in another peer group in the next test survey. So this is very important to note. You check your report from analyte 1 to analyte 20, analyte 1 to maybe 15 have IMR group. Then analyte 20 to 25 have only the general group or the instrument group without the M and so on. So this usually varies between survey to survey, because if this particular survey Instruments that are using the same method as you did not submit the AQA, they might submit in the next one. Another case might be ALT was not submitted by most participants in your instrument group, but the next survey they are able to submit. And this is usually very important to note when in differentials, since you are open to submit whatever you wish. You find that in your instrument peer group, some people do not submit the basophil differentials, they omit it. If the analyzers have issues in reading those particular differentials, they'll omit. And when you put it there, you're not getting the other groupings. But in the next survey, they put their results there. So that one will be dependent on how that particular question is taken through. So it's very important to note that this changes from test survey to test survey and analyte per analyte. You might be wondering why ALT, AST, and let's say calcium have instrument method, general, and reagent grouping. But when you come to CKMB, you only have general. That's dependent on how many peers are submitting in that particular event. And I hope the peer group is clearly defined. What are the evaluations criteria that are used? The evaluation criteria used to determine the acceptable range for each analyte is always shown in the last column of the performance report. For our case, it's usually on page 3 of the report where you will get the statistics. So when you see HB between 15 and 20%, this is the acceptable range, or when you have exceeded 20%, this is the acceptable. So this is very important when it helps us to calculate the standard deviations. So depending on the test program, our results may be evaluated against the peer group, predetermined, or a predetermined reference value. So remember, sometimes you might find that in a program, they are not using the mean group of the results, but they are using a reference or certified value. This usually is dependent on the kind of results that were gotten, and we'll see at it back there what affects the peer grouping or what affects whatever results that are being used. Also, for qualitative results analysis, we'll use a predetermined reference value. So for qualitative results, we are not expecting you to have 30 labs that were reported positive, then we say, okay, correctly, the results were positive. No, we'll be able to run it against a reference laboratory. And usually for EQA, I think it's subjected to about 10 laboratories, and that particular value is obtained as the reference value. So that when you have issues of other clients or other users who have failed that particular EQ, they can be able to pull that particular report and be able to identify. So at some points, you might find that some samples may be affected, and you find half of the participants got these results and half got these results. But according to the reference of the certified value, the results were varied. So let's go to quantitative results, and then we'll look at the summary for all of it later on. So this is what we are saying as the sign. So this is for users who are using our particular EQA. But if you're using a different EQA, you'll be able to get different highlights. And as I said, they might be green, yellow, red indications, marks, and so on. So these particular ones indicate a Z-score of 3 and above. So flag pattern. So for quantitative results, you'll get a flag pattern, high deviations on all positive or all negative. And let's look at it. So we'll get your instrument grouping or the evaluations that we have gotten. And as we say, different analytes might vary. So you might get only general for HCT and general instrument and so on. So this is your evaluation. This is your target value, and this is the SD. Remember, SD, we calculate it using the reference values or the acceptable limits in page 3 of our EQA report. Uncertainty is also indicated here, and this was discussed in robust statistics CME. Then we have the number of lab results and the lab result that you got, and the Z-score or the SDI. We are using them interchangeably, and then you have bias. So these two are important for your evaluation. How biased is your result, or how is your Z-score deviating? Now for HCT, the results one, you find that they have a Z-score of 0.4 and 1.4. So there is no mark here. They are able to pass, and they are within the perfect results. So how is the Z-score calculated? Remember, your lab results is only 1. But then we had the general mean. So generally, we have 163 labs who did this EQA, and they got this particular result as the mean. So we added A plus B plus C, and then we omitted the outliers, and then we got the target value. Remember, outliers are calculated, estimated using the robust statistics. So in that particular webinar, you are able to understand how you omit outliers and how you accept the outliers. Then you have the instrument group. Remember now we said as minimum of 5 participants. So there were 7. It means they were able to get an instrument group. If we had a reagent group, it will be listed here and their result. Instrument method group, it will be listed here. A method group will be listed here. But if there will be below 5, they are truncated to the next group. And the last one is usually general. So you have general, instrument, method, reagent, and instrument method. So if you don't have any peer group, it's truncated. That's why if we had failed to get 7 participants here, we would have been truncated to general. That's why in your report, you might only get general. And they vary between survey to survey. So let's say in the next survey, we have 10 new participants using the same instrument as you. Definitely, you'll get the instrument grouping. So how is that score calculated? The target value, subtract the lab result, then you divide by the standard deviation. So 20, your lab results minus the target over SD. So this is your lab result is considered as X, small x. Then target value is considered as the big X. And then SD, so 26.9 minus 26.48 divided by the SD, you'll get a Z-score. Now remember, individual Z-score also appears depending on the grouping we have. So it will be 26.9 minus 26.48 divided by 1.06, our Z-score is 0.4. 26.9 minus 25.47 divided by the 1.02, we got 1.4. You can do these calculations on your own. So this is important to note, because if you have failed this particular EQA and you came and rerun the sample, definitely you need to calculate your own Z-scores now. Because now if I rerun HB in my machine and now I got a result of 9.5, it means my results have changed and I'm not using the same Z-score. So you need to be able to calculate your new Z-score so that when you're doing your corrective actions, you'll be able to post your new results. And then we'll have the bias. Also, bias is calculated, but for EQA, you'll not be able to focus more on it, but it will help you know how far you are deviating from the general or the target grouping. So why is HB failed? We have a Z-score of 7, -7, and -4, because our result is lower from this particular mean. Then we have MCH, the same thing, failure. We have MCHC, the same thing, failure. But remember, if our HB had a Z-score of -7.2, but our instrument group, our Z-score was -0.4, there will be no mark here. Why? Instrument group is the best group to characterize your grouping or your instrument. So even if general failed, you will not be able to get a failure. Remember the hierarchy that we drew? The instrument, method, reagent, instrument method, and then general. MCH, there is a fail, and so on. So what are the possible causes? So number 1, if you incorrectly reconstituted or prepared the EQA. So check if the IFU was followed correctly, the volume, and so on. So I've had a case where if tumor markers is reconstituted using 3 ml, then general chemistry is to be reconstituted using 5 ml. And for your case, you come and do the chemistry one the same as 3 ml. You'll definitely have that particular bias. So if you over-reconstitute or under-reconstitute, you'll get such kind of feedback. Sample mismatch. Check if the samples were mixed up. If you run as A and B as B and B as A, check how you submitted. If you incorrectly prepared your calibrator, so this might point out. So we'll be able to look at what factors point out to such. So if you are getting lower results consistently, you check if your calibrator was done okay. Adverse conditions during shipments of the samples. If you had very high temperatures that might have affected the samples, when you received them, it was stored in the pharmacy department at room temperature for 2 days before you went to receive to obtain them. Those could also point out as factors. Instrument malfunction. Remember, the chemistry machine is pipetting, and then when you put your sample there, so sample A you get good results, sample B you get wrong results. Could it have been that the pipette, when it was picking this particular analyte, it picked a bubble instead of the sample? Was there a clot? So also check on the machine alert signals. So remember, these are some things that are ignored, but the machines can alert you. There was a pipetting error for this particular sample or particular analyte. So ALT, it will give you an highlight on your end, depending on which machine you are using. So for our machine Snipe, it will give you an alert, pipette error. So if you're able to ignore that particular error, it might have been that the pipette did not pick the sample appropriately. So you either need to rerun before submitting those results. You can check that. So that's when you come and rerun that particular sample, you get very good results, and you're wondering how could it have been. It might have been that there was sample deterioration or sample issue at that particular time. Improper operation of the instrument, check issues, calibrator instrument settings, incorrect assignment of the peer group, method, instrument, or reagent. So sometimes you might fail, and I've had these particular cases several times, especially if you put the wrong instrument, you will be grouped wrongly. You put the wrong method. Method is very, very important. In our EQA, you usually have method groupings that is very, very important for us. So sensitive analytes like chemistry, immunoassay, you might find that method is the one that can make you pass or fail. If you select a wrong method, let's say you select other, and the method for your instrument is DGKC, those two things have very varied results. So you need to be very important. I know method for chemistry is usually very hard for us to get because you have to go to insert A, B, C and get each individual method for you to input. So at some point you might be so in a hurry, but at least as the QA officer of your lab, take some time to just go to each and every individual analyte and pick the method, because DJKC method and IFCC method will give you very varied results. Other will form you also a different grouping, because other is anything. Someone using a manual machine, whatever, they'll just put themselves as other. Dry chemistry is also a very, very different methodology from other machines. So it's very important that you check that. So go into Tika, confirm your configuration. It's very important. Since you configured in January and we are in October, it's very important to just go on there and check which methods or which groupings you have been categorized on. It can also help you get these other groupings that you might be missing out because you are just missing that particular grouping section. Quantitative EQA. So for the flag patterns, so high deviations of Z-score for almost all the analytes, if you are getting all positive or all negative. So this can be an example of the flag pattern. So we have already seen how that can be. So we have discussed incorrectly reconstitution, sample mismatch, inappropriate storage of the samples, incorrect preparation of calibrators, shipment issues, and so on. Flag pattern, high deviation of the Z-score. Almost all the analytes are positive or all negative. So same thing we have seen. Let's go to 1.2. When you are having a Z-score for almost all the analytes, positive or negative, so here we are having all now the indicative, and this is the small sign that we were seeing as a Z-score of between 2 and 3. So not considered a failure. So the failure will be indicated with this big sign and this other small sign. So same kinds of issues. So we'll look at the case by case as we move ahead. So you might have sample mismatch, configuration in Tika, improper instrument operation. So as you check this particular list, you'll be able to now end up at the classification or the grouping. Adverse conditions during shipments, incorrect storage, statistical evaluation by ESFEQA. You can be able to reach out if you feel that particular case is exhibiting in your EQA. Submission error, changing the sample, typing wrongly, and so on. So an individual analyte has a high deviation. So let's say this one, you can see now we have general instrument and method, and then you have your lab result. So check if you had an issue on typing. Now remember, like this particular gen target are 53, 57, and 57, and for your result is 8.52. So definitely check if you are using the right the right units, or you typed the value wrongly. So you need to be very keen on that. So this might point out to such cases, especially the units. So you find that you have units that are wrong, you'll be categorized or grouped very lowly. So if you have very high Z-scores at some point, make sure you check on that. And then you have typing error during submissions, use of inconsistent units, configuration error, instrument malfunctioning, no instrument-specific peer grouping available, or inaccuracies of the target values. When it's only in one group, check the instrument or method or reagent. Inaccuracy in target value can be also a factor. So you need to be able to check what is affecting in such kind of cases. For the updated kind of EQA evaluations, you will find that if this particular Z-score of one of them is very okay or not having a failure, there will be no big sign here. So you can see this Z-score is 3.1, but the big bomb sign is not indicative, but only the small warning signal. So high deviations either in the instrument, method, or reagent. So you have all the three groupings having a very high deviations. So we'll be checking the inappropriate instrument, method, or reagent configuration, inaccuracy of the target value, incorrect assignments of peer group, inaccuracy of the target value, incorrect assignment of peer grouping or agent. How are you able to identify trends or shifts? So these are very important to note. So go to your Schwartz chart or check your cycle report. So a Schwartz chart is usually in each particular report from page 1 to 5, that's a summary. Then you have a very heavy 5 to 96 or 5 to 150 pages. What do you do with them? They are very important to give you. So for that particular EQA, wherever you started, there will be a graph, a Schwartz chart graph that is indicated for how you have been performing all through. So that if you are able to see a shift or a trend, it's easy to identify. So this lab started in 2021 and they have been doing cycle 1, cycle 2, cycle 3 up to this. So they are able to run the EQA. So they started well, they went well. Then when it came to this cycle, you can see there is a kind of a trend that is raising, whether positive or negative. So here they got, it went higher, it went higher, it went higher. So what is expected of this lab? The results are still going to be high and they are going to exceed the 3S DIT for failure. So they need to check. So what can be causative agent for this? Outdated calibration. So depending on how frequent the calibration is done, this might be checked. So they need to check the validity of the calibration. That's why in your EQA or your instrument, they'll be able to say calibration is valid for 28 days, 30 days. You need to follow that. So that before you run your EQA, is your calibration valid? Remember, the reagent at day 1 of your calibration is not the same reagent at day 30 of your reagent of your calibration. It has deteriorated. So you need to recalibrate to put the reagent in the same level as your sample or your EQA. But if you are using a day 1 calibration when the reagent was new, it will be very varied. Remember, those days are indicative, and some instruments will give you alerts where the calibration is off. So if you ignore that, it's on you now. But you'll find that all reagents will have those particular alerts, have them uploaded on your machine so that it alerts you when the deterioration is happening. Because that's the study that the manufacturer has done over time. Aging reagent. So let's say you put reagent in March, and then the EQA is now in, let's say, cycle 4, maybe in July. So if you're using that particular same reagent, check if it's aging. And especially if you have not recalibrated, it can be an issue. So check if the reagent has been aged. So that's why it's very important on your analyzer, indicate the date the reagent was loaded on board. Inaccurate volumes of reagents can also be a form of factor. So if you're using the reagent that is at the bottom of the bottle, so depending on your machine, how does it omit that particular carryover and so on, you might have those particular issues of the reagent being diluted with particles. If you don't cover your analyzer, remember, dust is in the air. So dust will be able to settle in your reagents. And as dust settles inside, depending on which environment you are, it will affect. You are having machines that you've left the reagents on board overnight. Do you have a good backup system for the building and for the machine? Because remember, at midnight, power might go off for 5 hours. When you come back in the morning, power has returned. So for you, you are still assumed that your reagent was perfect all night. But from maybe 12 midnight to 7 a.m., the power was off. Remember, reagents also deteriorate. Instrument maintenance, review with your manufacturer or distributor of the maintenance of the equipment. All right. So occasionally high deviations of Z-score for individual analytes, Shewards. So improper operation of the instrument, incorrect handling of the EQA, adverse conditions, or concentration of the sample beyond a range. So this is a case where you're finding it's not consistent. You're just having very varied kind of peer or a Shewards grouping. So this might be indicative of those particular reasons. Positive or negative trend of the Z-score. Seen this particular one as well. This one we have already discussed. For qualitative results, it's direct. You have a recording error. Did you report positive while it was negative? Check your results that you had put. So remember, when you're submitting it, you usually ask you to print your raw data to confirm you had submitted and also to confirm your results. So raw data is when you submit your results, you click print your results tab. So that's very important for you to do so that you can check, did I put positive instead of negative, and so on. Sample mismatch in case you mix the samples. Use of an inappropriate cutoff. So remember, when you are running that particular RDT and you are having an issue with the cutoff, so did you confirm as positive or negative, but it was the cutoff that was of issue? It's very important for you to note. Insufficient sensitivity of the used device or the kit. Adverse conditions during shipments can also affect instrument malfunction, inappropriate operation of the instrument, incorrect peer grouping, or incorrect handling of the material, especially on reconstitution. So let's go and discuss now those particular cases in the questions. So what or why? Apologies for that. From my side, so just setting up a hotspot. So I hope everyone can hear me. You can just raise your hand or put a reaction if you're able to hear me. Thank you. All right. So it was just a power issue from my end. So let me just put up the presentation. So we had stopped here, where now we are going to ask the questions of why. So we already discussed. So this was just an overview on how we will be able to understand the reports that we handle day in, day out. So ask the question and see how we should be able to answer them. Okay. So what are the possible sources of errors to cause the unacceptable results? So always you should ensure that your registration is correct in Tika. So that's the first thing that you need to make sure you have done. And remember, configuration is opened every cycle. So it's very important for you to just go in there and check if you have missed anything, especially units, method configuration, the instrument, or the reagent. Remember also, if you have changed the instrument, don't forget to do configuration. If you are using a Sysmex and you've changed to GenRui, remember you have to change for you to get the best grouping. If you have selected the incorrect reagent, instrument, or sub-method, it could cause your results to be evaluated in the incorrect peer group. And as I've said, method grouping for chemistry is the worst that causes many failures. DGKC method will give you a very different method results from an IFCC instrument. So make sure you go to your instrument reagent insert sheet and confirm the method grouping. We have solved so many cases on that particular one. And if you ignore it, you'll just get the same kind of feedback every cycle. Sporadic test results identified as unacceptable can be classified as random errors, while series of test results identified as unacceptable may be due to systematic error. Remember, when we started, we had to define systematic and the random errors. So you've been doing so well, and out of the blue, you get a failure. Can be classified as a random error. And then you have a systematic error, as we have seen in the trend graph. All results have been consistently on the upper side of the LJ or the Shewhart chart. So we'll see us at this particular one. So in the next table, so for pre-analytical, make sure that you focused on, so these are random errors. We are distributing them between pre-analytical, analytical, and post-analytical as a summary now. So pre-analytical insufficient sample mixing, especially following freezing or samples requiring good homogeneity in hematology samples. Remember, when you are handling that particular EQA, you are handling it correctly. So for hematology, make sure that you are mixing using the palm of your hand sufficiently and you are inverting it 10 times. So also remember that once you've removed it from the fridge, you have to make it attain the room temperature for 15 minutes before you start mixing. EQA, subject it same as your QC material. Do not use a roller mixer for EQA, no matter how tired or how busy you are. Don't put the EQA samples on a roller mixer. So the most important thing that why we are doing the palm of the hand and inverting it 10 times, usually is for you to observe on the bottom of the vial or the tube, has all the sediment been mixed appropriately. So when you invert it, you need to get a clear tube outline as compared to, let's say level 1 will be might not be so showing. Level 2 or the normal can have, but the 3 usually you'll find very dark sediment on the, so those cells are not sufficiently mixed. Now remember, all our analyzers pick the sample from the bottom of the tube. So if you are running your EQA and you did not mix it very well, and the top part, the bottom part of the tube is still very dark or very red, remember you will pick the red RBCs highly concentrated. You are leaving the buffer up and you are picking the highest concentration. So what will happen to this? You'll get very varied RBC and its factors, or varied HB. So you are must be very keen on that. And analytical, now pre-analytical is how we were mixing. When you are doing the other point that you might add here is reconstitution. Remember the case I told you, if you are doing tumor markers and chemistry, but tumor markers has an instructions of using 3 ml. but you are so invested in the lab that particular day and you forgot chemistry was 5 ml, or you did not check the IFU and you used 3 ml, 3 ml on both, you'll get that kind of indication. So when you check your results, you're finding that everything is positively biased because you reconstituted wrongly. Remember, for chemistry also, we discussed last time, you have to allow it to attain the room temperature 15 minutes before you mix. And once you reconstitute your 5 ml, remember you put it in the dark without mixing. And after the 30 minutes or 20 minutes that is instructed for you, then you'll be able to reconstitute or mix. Remember, as Antony had discussed in the previous webinar, conditions that you're subjecting this particular analyte will determine. So you have bilirubin, and for you, you have a very brightly lit laboratory, and you put your vial that is dark closer to the window where it's hot or closer to direct sunlight. It will affect the particular analyte. So remember, you have to put it in the dark and store it appropriately. So those are just some of the things that you need to focus on during reconstitution. Remember the water, also what you are using in reconstituting. The best or the ideal, we usually say in laboratories, use deionized water. So deionized water, you can just get a small vial, a 5-liter tank, and put it in the lab. So despite them buying for you distilled water, just have a deionized water, 5-liter, put it separately for reconstituting of your QCs or your calibrators or your EQA. Because usually issues that come with calcium failing, potassium, sodium, chloride, all these ions, usually you're using distilled water. So this distilled water, do you also subject it to tests? Or is just that the distributor that was given that particular role by maybe your lab manager or the director or the procurement, they're just selling you the distilled water. So have you tested that particular water as a laboratory, or have you asked for that report from the distributor? So you need to be very keen on that particular sample reconstitution process and what you are using. If all goes very highly, I usually say you can use the water for injection. At least that one they have been able to test it, and you can check on those particular reports that are available online. Check water for injection, check the manufacturer, and be able to Google it, go to ChatGPT, and it will be able to give you the reconstitution or the percentages of the solutions that are there. Also, the water that you're using a tank that you usually open, leave it open for a while before you close it. That 20-liter bottle also gives very varied results. So very important to focus on the pre-analytical procedures. Remember also when you're mixing that particular sample, they tell you to swirl. Swirling is put it on the table and now rotate it clockwise. It's on the table, rotate it clockwise like this. Don't lift it up and now shake. The bubbles creation usually affects reconstitution. And remember, that stopper that comes with the EQA has dust particles for that particular analyte. Remember, you have to invert it upside down for at least 5 minutes so that it can also dissolve those particular aspects that are on the stopper. Also, opening of the vials, you have EQA A and EQA B, and you're using the same hands to open both of them, and you're not using that cap to open, can also point to issues where if you open with your hand and then it pops out, if it goes and hit out, the dust goes off, it affects your reconstitution. So very important to focus here. Poor pipetting are some of the random errors. Remember, when you're pipetting and you're creating so much bubbles in your tube, the pipette will definitely pick the tubes. Remember, the chemistry analyzers have sensors. So the sensor is what usually determine which level I'm entering. So if I'm having this particular tube and my level of EQA sample is here, the pipette will go. The moment it detects a signal that it has reached some liquid, it stops. So if it stops at the bubble, remember it will aspirate the air. That is for ALT. When it goes to AST, the bubble has disappeared because it has been punctured. Now what does it do? It goes into the liquid now. So when it goes into the liquid, AST will pass. Another analyte will pass. Another analyte will pass. Another analyte will pass. But you are having ALT that it will give you very wrong results because it aspirated air. So the reaction was happening between reagent and reagent 1 and reagent 2. So you might find that what happened to this, but when you do a rerun next time, you find that it's correct. Then sample mix up. Remember, this usually happens a lot of time because you are having sample A and sample B, and you put your instrument. We usually put in sample cups when you are loading because usually the tube cannot fit directly in the machine. So you are distracted because you are alone in the lab that day. A patient comes, rings the bell, confusion happens. You go run, pick their sample, come. When you are here now, you're not sure which sample was A and B. So do those pre-analytical steps where usually, for lab, you label the tube first and then you reconstitute. So don't label A and B at the same time, and then now you start putting inside them. If you're focusing on sample A, just do sample A, reconstitute, put it there, put it on the analyzer on the correct position, and so on. So sometimes also it happens where you might have a sample position, some patient sample on position 5. Position 6 you put EQA, position 7 you put EQA sample B. But in your analyzer, you mistakenly put 5 as, which is the patient sample, as EQA A. Another one EQA B. So that can also give. So whatever, because you don't know the EQA results. So it might give you same results as the patient sample, but you're not sure what. So those are some of the key things that you need to check on, especially on sample mix-up. And this one you can easily identify it, especially on random errors. Testing not performed immediately after some vials are opened, example for blood gases and so on. So remember, if you're doing blood gas, when you open, you run it immediately. Once you reconstitute your EQA, run it immediately. Or if you're not running it immediately after reconstitution, put it at 2 to 8 before you run. If you freeze it, remember, you have to thaw it only once. But the best thing is before you freeze that particular EQA sample, make sure you run it. So usually it happens where you've reconstituted for 30 minutes and then you leave it in the dark in room temperature for 2 hours, because at that day the patients and everything is not working. The patients are coming in plenty, you are alone in the lab, pressure is high, and you forgot your sample. So at that point you'll call us and saying our EQA is failing and so on. But at the background of it, you need to understand that how you handle that particular sample will affect. Blood samples for EQA for hematology, after you remove it, after 15 minutes, you've mixed and you are able to run. Ensure that you run it immediately and return it to the 2 to 8 temperature. High temperatures usually causes deterioration. So if you leave it for 2 hours and then you come and run, that can be an issue. Dilution related problem. So wrong dilution factors. This is clearly well understood and important. Remember, a calibrated pipette is what we use at the lab. Do not use syringes. Syringes is a shortcut, not for lab personnel. Leave syringes at the phlebotomy area. Ensure you use a well-calibrated pipette. And how often do you calibration for your pipette? Your QA or your lab manager should be able to put that as a policy in the lab, that you need to use the correct pipettes. You need to be able to be sure of this volume. Is it 1 ml? Remember, 5 ml. If I reconstitute my EQ with 5 ml, and another person reconstitute using 4.5 ml, and another one reconstitute using 5.5 ml, or even 5.01 or 5.02, these varied results will incorrectly give you wrong results. So use a pipette, forget about syringes when you come to laboratory, and it should be a calibrated pipette. Suspected or known imprecision problem with the test. If you're having an issue with that particular analyzer or that particular reagent, cross-contamination or carryover, has your machine given you a report on cross-contamination or carryover? Does it do that particular cross-contamination test after the analyzer has finished? You'll see that in several machines and so on. Mislabeling of sample in the sample rack. So this is when you're loading it on the analyzer. So we have been able to see that particular one. The post-analytical errors, usually, number 1, transcription errors. You have a printout, you have seen 20, and you are writing 2.0. So that's why I usually say, at least have a second eye check on this, because doing a root cause analysis for transcription errors should be legal. Because you need to check, and before submitting, because there's usually no hurry in our EQA submission. Remember the portal, once you submit that EQA, you have at least 10 to 15 minutes before it does a reset. So you can be able to be keen on that and be able to do that particular one. Also in our EQA, you'll find that when you're submitting as a result here, beside it, you'll find the units. So have you confirmed your units? Because you'll find that you have cycle 1, 2, 3. The person has been having very wrong results. And then in cycle 4 is when now they realize, I was submitting using wrong units. So be keen on the transcription errors. Incorrect results units submitted. This also should not be. For a quality lab that you've attended, a good training, ensure that incorrect result submission should not be a factor. Incorrect sub-method, remember this also fails. It's the best culprit for this is usually chemistry. Different methods give very different results. Be keen on this. Online results entry typos, these are same as transcription, or transcription can also arise from you don't have a printout for your machine. So let's say a chemistry analyzer, you don't have a printer for it, and then you transferred the results from that particular instrument to a paper. Then now from the paper to the system. So that usually can lead to transcription errors. Online typo will be same as what we have seen. Calculation, manual and automatic errors. Remember, your lab, the machine, chemistry machine can calculate for you LDLC, but for you are calculating manually. So if you do that, remember, you've not run LDLC, but you have done it manual calculation. Remember, you need to be keen on the calculations, because the typing, the calculation that you're giving can give you wrong results. Result unit conversion not done or done incorrectly. In case you are, that's why usually during configuration, you have to check the the units first, so that if your result is G per L and you need to submit in G per DL, you can now convert manually and have errors. So usually it's very important for you to just assign the values as how you report misgraded or misinterpreted results. For systematic errors, you'll have inaccurate reconstitution. This is the pre-analytical. So in inaccurate reconstitution, wrong diluent amount, you are told to use the diluent used water and so on. Insufficient mixing or centrifuging before the test, incorrect storage of the test kits or the EQA itself, compromised samples during shipping. That's why it's really very important for you to fill out the sample condition form, so that you can be able to now defend your report that this particular case, I received the sample in these particular conditions and I raised it up, and this might be the cause. So we'll also help you do that troubleshooting. Temperature of samples not proper for running or for storing. So you have removed the sample from the fridge and you immediately reconstitute and you immediately do the running. It will definitely fail. That particular time they tell you wait for 15 minutes, wait for 30 minutes. You follow it to the latter. Reagents contaminated, this is the now analytical stage. Contaminated reagents or expired, instrument error or malfunction, parameters for the instrument you have changed. Remember, the parameters is like for chemistry, let's say ALT. The result should be ran at wavelength 18, using wavelength 450 and 600. For you, you come and change from 400 to 550 and 700. When you change that, definitely wrong results. When the machine was supposed to read the reading, first reading, second reading, if you change that times and so on, brings so many issues. Ineffective or inconstituent washing, this is in case of immunoassay. So if you're using a clear and you reconstituted your wash buffer wrongly, it means that you're washing away your beads, you're washing away your antibodies, you're washing away your antigen, and so on. Contamination of the equipment, remember the probe as it goes, it needs to clean. So that time there was an alarm of water is insufficient. Water is insufficient, and for you just continue running. You continue running. It means the probe is now not cleaning itself. So it's entering into sample A, go to wash station, no water. It still continues. For it will not stop. It will alert you. So those are alerts that we usually say when you have failed your EQA and you ran the EQA on 18th. Go to your history of your analyzer and check if there is any historical data of errors or malfunction during that particular day. Because if you see pipette error, you know pipetting was affected. Clot error, it means that the pipetting of that particular sample was not correctly pipetted and so on. No water in the instrument, and this. You know that the cuvettes were not washed correctly, the pipette was dirty, so it means you picked sample A and you transferred it to B, and so on and so on. Calibration related issues, not calibrated. Usually this one falls when you see positive, check on your IQC and then check on your EQA. This usually cause calibration results drift, because the optimal calibration for day 1 is not the calibration for day 28. And calcium, if you are to calibrate it every 7 days, and for you are calibrating it after every 28 days, you can see where sources of errors come in. Wrong assay used for testing the sample. This one comes in when the analyzer that we are using, and sometimes you are not using the barcode scanner for that particular analyte. Or for the case of immunoassay, you scanned the PSA and you loaded TSH. So if you are using the wrong assay, definitely wrong reaction. Or you are using the reagents where you put on the analyzer and you are the one to manually tell which one is this. And remember, sometimes you forget to label even the battles. So I am Ayub. I know I put ALTST 39. But yet tomorrow morning, another lab tech doesn't like your follow-up of ALTST. They interchange. So it's very important also to take note of that. So you can use AST to run ALT and so on. So you need to be keen on that. So usually that's why you say if you're using the automated systems, make sure that every morning you're able to check the scanning of the reagent and you're able to know which reagent is where. Because especially for high throughput labs or busy laboratories, you might find very interesting team where one wants to put this way and they interchange the reagent. If you don't know, they will be having issues. Then on systematic errors for post-analytical will be incorrect sequence of results entered during online results entry. So if you're having ALT, AST, calcium, creatinine, and then for me, I come and now put calcium, creatinine, and so on. So sometimes that can also happening. That can also happen when you follow the wrong format. So sometimes you find that the report for hematology will give you a certain format according to your printout. But when you did configuration, it gives you a different follow-up. So you need to be very keen on what you are submitting. So if you are submitting calcium, you need to put it under calcium and so on. So do I need to do anything further if I do not have any acceptable results? Yes. So even if your results are acceptable, you can determine if the trends are developing and you could run to an issue in the future. Remember that graph where we are saying you are on 2 SDs, but your deviation is starting to climb up. You need to check on that because the next time you'll now be at 3 SDs. The best way to detect these problems, examine the SDI. Although looking at the SDI will give you a quick interpretation of your results, you may have unacceptable results within small SDIs. This can occur if the evaluation criteria do not use the SD to generate the acceptable ranges. If your EQA data has a Gaussian distribution, then 68% of results should fall within 1 SD, 95 within 2 SD, 99.7 within 3 SDs. Therefore, you should want the EQA data to have the smallest SDIs closer to the target and have both positive and negative SDIs for any given analyte to eliminate possibility of bias. So same thing we usually do in LJs for QC is the same kind of distribution you need to see in your EQA. So performance reports will give you SDI, and we said SDI or the Z-score is your result minus the peer group divided by the SD. Small x is you, big X is the mean over the peer group SD. I have unacceptable results. Now what? Determine what caused the unacceptable results and take corrective actions. All EQA errors must be thoroughly investigated and documented. Investigation should include the following steps. If you have a Z-score of plus or minus 3, there is high probability that random error might have occurred or transcription. Review the report carefully and determine if the clerical error or problem mentioned in table 3 with a focus on post-analytical errors. If there is more than one result that have greater than 3 SDs and the SDI difference is also large, if so, there is high probability that results entered using the wrong unit or they were mixed up. Review your copy of the original EQA data submission form. Remember that printout is very important. You need to put it and you compare it. So if you submitted 20, go to your printout and check if you submitted really 20. If you have any issues now, you raise it with the EQA provider. I submitted 20, but my result came in as 2.0. You should look for transcription errors, transposition answers, coding errors, miscalculations, and so on. Review all results, printouts from your instrument. You should look for incorrect units and so on. So you have to print out. Do you have unacceptable results and all situations have been ruled out and you do not apply? If clerical and transcription errors are ruled out, systematic error could have been happening, and find the sources of the systematic errors to be investigated. Review your QCs for that particular same day. Was the EQA result accepted when QC was not out of control? Remember, you submit your EQA, but IQCs had failed. That can also point out to an issue. Review the calibration data. When was the calibration done? So go to your that day and check. You ran the EQA this day, but the calibration was done 2 months ago. Did it fit the requirement of rerunning? Review your registration in the EQA portal. Retest the original EQA sample. Usually say don't discard. Do that. Retest the original EQA sample and so on. So the same case, if the result is out and still unacceptable, rerun. Review quality management tools for your lab. Ask the laboratory person who performed the original test to see if the testing was handled correctly. So if you're the lab manager and you're reviewing, you can also check on that. Determine the corrective actions that you need to do. Do you need to recalibrate? Was it a random error? Did you find the source of the error? And how were you able to check on it and handle? Ensure you can explain all your unacceptable results is very important, and your instrument is producing accurate results. Continue to monitor the QC after the test event. Document your investigation and corrective action. So usually you find that we'll say that our IQA failed, but our IQC has been consistent pathing and so on. We'll be able to check on it as well. So you have done another evaluation and you're still having issues. Check for historical performance. This is usually getting on the LJs or the Shewart chart or the cycle reports. Could be the case that you need to help you monitor the trends or shifts of that particular data. Check if it's a systematic error over time, because you have two examples have been included for demonstrations of the shifts. So remember this one you have seen, you are performing well and then it started going up or above. So that positive SDI can be indicative of that particular shift for that particular run. And then you have a consistently failure. So this you can also interpret it for the IQC and for the EQA. So you need to check this before you submit your results. So if you're having this particular trend, it means at the end of it, you're still getting the same kind of positive bias for that particular sample. So the test event usually consists of 2 or more samples and they span different analytical ranges. It will help you investigate which levels of samples suffer from higher unacceptable results. So if you're having the level 2 is the one that is having very high failure rate, you need to know you need to check on now your other aspects of accuracy, precision, and linearity. You might be failing because the machine is not be able to read those particular high levels, especially for where cases you get zeros in hematology for differentials and so on. So that can point to that particular issues. So if you're not evaluated in peer grouping, either I, M, R, or G, so usually the case is for most peer groups, you need to have at least 5 participants. Some statistics or some reports will require 10, but usually the baseline is 5. So if you don't have any peer grouping for meeting 5, you'll be truncated to the next grouping. Then having your results evaluated with a larger peer group would mean an adjusted evaluation. So sometimes you find in chemistry, you find that there is no, let's say CKMB. You did the EQA, but there is no report that you get for CKMB. Usually sometimes it's because of this. We have very high number of participants and they are giving very divergent data. So even if we analyze, we'll analyze or classify you wrongly. So usually they omit the evaluation and you'll find it in the report comments. The DGKC method for CKMB was not evaluated because of ABC. So you'll find that particular case. So if you don't find any classification, sometimes it's divergent data from a bigger group that does not give proper evaluation. It has been documented in some studies and articles that bias often sometimes is seen between assays. In other words, because of the inherent difference between instruments, reagents, and methodologies, the bias between groups, oftentimes it's best to evaluate with a more specific similar peer group or broad peer groups. A larger peer group means that the bias effect will be incorporated as well, which might falsely increase the acceptable result. So we'll omit that particular evaluation if we are seeing unfair distribution. So once you download your EQA report, they will list different evaluated peer groups, and we have discussed with which the groupings are. Even though your own peer group is not available, it's still beneficial for quality assurance purposes to examine the report. So if you don't see your peer group, it's still very important for you to evaluate that particular report. So that's just a summary of our EQA programs and the vials. So you'll get lyophilized or liquid samples. The IFU is very important. Don't run the EQA without reading the IFU. And if you've been running our EQA since 2020, so you have crammed the IFU. Remember, each and every survey, the IFU must be read. Remember, for urinalysis for case of this year or this cycle, we've been running urinalysis that is in liquid form from, let's say, 2017. But this year, when cycle 3 came, we have introduced lyophilized urine samples and then another sample that is in liquid form. So if you don't read the reconstitution instructions, you might feel like, oh, I got the wrong samples or the samples have dried and so on. So remember, each and every survey, just take 1 minute to read the IFU. You'll get the changes or check on the stickers. Sample reports. So the conclusions or takeaways, EQ troubleshooting is a structured process. Remember, identify where the error is: pre-analytical, analytical, and post-analytical. Identify which error you are having. Is it a random error or a systematic error? Once you define those two particular processes, your troubleshooting is easy. Early detection prevents failures. Check your Schwartz chart, check your cycle report. You'll be able to identify shifts, trends, or random errors. Continuous improvement is definitely the key. So those are our contacts, and that marks the end of the presentation. We can now go to the Q&A. Apologies if the report, the presentation took quite some time. We wanted to be as detailed, and thank you. So let's have the Q&A session. Mr. Antony is in the meeting. He'll be able to also respond to some of the pertinent questions. Thank you. Okay, so let me put the mic open. If you have any question, you can feel free to unmute and ask your question. You can just raise your hand. Or you can put the questions on the chat box. So the mic is open for anyone who wants to ask a question. Thank you.
Okay, good morning. Feel free to ask your questions. You can put them in the chat box so that we're able to handle them in the next 13 minutes so that we are able to be done by the end of the hour. Sorry, by 8:30. Thank you, Samuel Karega. Okay, good presentation. Thank you for that. We have David Judah. Okay, thank you for that presentation. Okay. Violet as well. Okay. Nelson is asking, thank you, Ayub, for the good presentation. Could you elaborate more on cutoff that you mentioned earlier? So, Haroun, you want to respond to that?
Yes, Nelson. So cutoff would mean, especially for things to do with immunoassay and let's say the RDTs. So remember, for chemist, an immunoassay analyzer, let's say we are running HIV and we are using an automated platform like Roche, or we are doing HIV viral load. Remember, there is usually a cutoff that is given by the reagent manufacturer or the instrument manufacturer, that beyond this is positive. Below this is negative. So if you have not focused on the cutoff very well when doing that particular reporting, or you get a result that is below or intermediate within the cutoff and you submit it as an alternative of what the manufacturer had instructed, it becomes an issue and you get a wrong result. Case in point, you are using H. pylori urea breath test. And for this case, they tell us the 40 and below result is considered a negative H. pylori report. Above 50, considered a positive H. pylori report. Now, when you do a run and it gives you a 45, and you did not focus on this. So if you say that my cutoff is okay and I report it as a 45 as negative, I might be on the wrong side of the result. So you need to check if you are able to do a repeat and so on. Cutoff could also present when you are doing molecular or immunoassay. So for molecular, remember when you are doing COVID, they were telling us a positive cutoff is for a certain reagent is 40. But we were shifting between different reagents, different manufacturers. So you find that Vitasay have said their cutoff is 40. When you go to a different manufacturer in the UK, they tell you the cutoff is 35. So if you're able to report 38 as a positive COVID-19 result, as compared to between 35 and 40, you might find that you are giving wrong results. So that's where the cutoff is very important. So for RDTs, it's clearly defined because you might have that particular intermediate area. So you need to check where am I falling, or for automated analyzer, check what the cutoff of the manufacturer is saying. If the machine is not giving you the interpretation, sometimes remember the machine can give you an interpretation. We are doing quantitative for HIV and you get a value. So that particular value, if the analyzer is not interpreting for you as positive or negative, and it's for you to interpret, you need to focus on the cutoff, because cutoff will vary between instrument and vary between reagents.
Okay, thank you for that. Daniel is Sahara Abdi, thank you for the good presentation. Okay, we have Daniel Wekesa. Thank you so much for the wonderful presentation. Between distilled water, water for injection, and deionized water, what is ideal for constitution of reagent and IQC materials?
Okay, so take as water for injection as an A or B. So remove it from the picture. The instructions for use for all manufacturers, they will tell you use distilled water or deionized water. So it's up to for you at the laboratory to ensure that you followed the instructions. So case in point, we are having a reagent or an instrument from Europe. So when the instructions for use indicate use distilled water, they have put in mind or assumed that the quality of water that the lab is receiving, for them to call it distilled, is as per specifications. And then I have now a machine in Kenya. I've installed it, let's say, in Homa Bay, and the facility is producing their own distilled water. If this water is not tested, it will give you varied results. But you will say, I've followed the manufacturer's instructions. So remember, all instruments or even all machines, they'll have an instructions on the quality of level of water that to be used. So if it's, let's say, a SNIPE chemistry machine, you'll find that they will tell you use water class 2, and they'll have a number that they have given there that tests for their the conductivity of that particular water, and they'll tell you that water should be having a minimum of 3 conductivity microns. So for our case, if you are using facility-based water, has that particular report been given to you as the lab? That the persons who installed that particular machine or serviced that machine and they have tested that particular water, have they given the lab the report? I'm buying water from a vendor. Has the vendor given you a QC report for that particular water, or a testing certificate for that particular water, so that you can clearly say calcium tested 0, this tested 0, this tested 0, and so on. So you need to be very keen to ensure that you have followed that particular instructions. There are very other strict instructions where they will tell you use deionized water. So especially for things that we are having to focus on ions, the instructions will be very clear. Use deionized water. So at the end of it, all debates coming in and out, deionized water is usually the best to use because you have ruled out the issue of affecting your ions. But in chemistry, they will tell you use the distilled water. But if you're having issues or having to run ions in that particular EQA for combined EQA, sometimes you might find an EQA, it will combine certain analytes and then ions, it are separated in a different vial. So you need to be very keen. But if you're having them all combined, deionized will be the best water to use. And if you're using distilled water, make sure you have tested it and you have a report for it. And it should be often, so they don't give you a report in January and then they supply you 1,000 bottles of 20 liters and you don't get a report for each and every batch. So make sure you get a report for every batch and so on. And if you're testing in-house, make sure that you get a report from the installer of that particular deionizer or distilled water. So what we usually say with the water for injection, you can easily go online and get a report from that, was the water used by, let's say, the nursing department or the doctors. So for it, usually at least the purity for it is at least well known because it's something that has to go into a human and it has to reconstitute medicine. So they are very keen on interaction between this medicine and this particular water that is used. So that's why we usually just say, for cases where tumelemewa kabisa, hatuna report ya maji, or we are using our own, it now becomes easy for us to have an alternative, and we'll say we're using water for injection. But it should not be a factual thing that you're using in the lab. Focus on the IFU. If it says distilled, ensure that it's distilled. If it says deionized, say that it's ensure that you use deionized. I hope that is clear.
All right, thank you very much. So virtually, distilled water and deionized water must also be accompanied by certificate of analysis. So the certificate of analysis will be able to have the data about the analysis of that water, and you can also still go ahead and verify that whatever the manufacturer or the distilled water source is coming from, the values that you're being given there are actually true, so that you don't have those interactions or interferences between various analytes and ions in between. So ensure that the certificate of analysis is there, and then you do the verification process of that particular certificates that you've already given, so that you can also actually check whether it makes sense. I don't see any other question on the chat box, so we have like 3 minutes. Anybody who has raised their hand? Okay. So if there is no any other question, I think we'll want to end it there. And thank you very much for the opportunity to present to you. I think we're in our 6th round of webinars since we started. So virtually see you next week as well, same time. Over back to you, Haroun.
All right. Thank you guys for attending. Feel free to also put your comments if you have any issues. We'll be able to share the meeting notes or meeting video with you as well for review. But as always, we appreciate your attendance. Thank you and have a good day ahead. See you next week. Bye-bye.
Bye-bye.